Go.
Hello, my name is Brian Groh. I'm with the FARO Customer Service Department, and I am here today to talk about the FARO Target Tooling Kit that comes standard with laser tracker and is also part of our accessory catalog. It comes in that case right there. It does have a couple latches on it to allow you to open it up. And it has the tooling nestled inside of it right there. It does have a couple of open spaces for some additional tooling if you choose to get some additional tooling. I'm going to go through each one of the individual pieces of tooling and some of its purposes, some of its popular applications. There may be some additional applications. Obviously, you can always think outside the box. First thing I'd like to go over, and I'm having a hard time getting it out. And they are somewhat jammed in there. But right over here and right over here are a series of 5 nests. They are all magnetic, which is why they stick together, but they are individual nests. These go by several different names amongst our own internal people and amongst customers, amongst tracker users. They are generally considered heavy-duty drift nests or just a heavy-duty nest. Their purpose is to allow you to place them onto or on or around the measurement volume to allow you to monitor drift, monitor movement of the tracker, of the object itself, or as the tracker is a line of sight device, if I have the tracker over there in that corner, I may not be able to see items on this side. I would need to pick the tracker up, move it over to an area on this side, and do a device move. And if these points are affixed to the object that you are measuring, then you are able to take the measurements from the tracker in its position over there, take the tracker in its position position over there, take the same measurements, and do a device move. And the software will figure out how to calculate out the new measurements in the previous coordinate system. These are the current style of nests that are shipping with trackers and shipping with the Target Tooling Kit. That is as of fall 2011. There are older style nests that are a different form factor. They are slightly larger, but they perform the same purpose. Okay? These are not precision, and right now they have no glue or anything like that on them. I cannot give you exact dimensions of these, and its purpose is not to, there is no need to give you exact dimensions on them because they are not precision. The way that I would use this as a customer is hot glue them, either place some hot glue on the bottom or on the edge, and glue it to the object that you're measuring. And then when it comes time to take them off, I would take a small hammer or a small piece of stock metal and bang it off. So at that point there, you would very commonly wind up with small nicks and or pieces of glue that cannot come off. That does not matter because they're not precision anyway, and it's not needed to be. The only thing that is needed is that the SMR sits in a repeatable position no matter how it is placed. It is a 3-point contact, so if I place the SMR in there from that orientation or in that orientation, the center of the SMR is always coming back to the same exact location, which is why I can use that to monitor drift, monitor movement of the object or the tracker, or do a device move with them. Next tools I like to go over are what is commonly referred to as the 1.5-inch shank nest, or a 1/4-inch diameter shank nest. Goes by a variety of different names: pin nest, shank nest, quarter-inch nest, etc. It is a nest that you place the SMR in. This is precision, unlike the unlike the heavy-duty nest. This is precision, and if I place the SMR in there, the center of the SMR is sitting 1 inch off of this surface. There is a quarter-inch shank or pin that extends from the bottom of the nest, and it mechanically aligns the center of the SMR so that it is in line with that pin. If I was to place this nest along that surface, along the surface of this circle, then even though that circle is much smaller than the actual SMR, I can go in and I can measure this hole. Okay? Through the software, because this is a quarter-inch diameter shank or diameter nest, the software will apply an offset, provided that you choose the right target. Provided that you choose the right target adapter. It also knows I'm also 1 inch flush, 1 inch off the surface, so I can then also therefore offset 1 inch down off of the surface. Once again, the software takes care of all of the offsets. Many of the newer nests that are coming out have this cutout that allow you to place the SMR down, pointed down just a little bit. Not all of them do, and many of the older ones do not. This is a newer feature that is coming out on many of the newer nests, and as we are rolling some out. But you can see when there is no cutout, the SMR does not get quite as much field of view, and that's sometimes useful if you're measuring something up high. The standard target tooling kit comes with 2 of them. This is one of the most popular pieces of tooling that is used. There are other sizes available. They are all typically 1 inch offset. However, their shank diameter would be different. If a quarter inch was too big, say for that hole right there, a quarter inch would be too big. I would probably want 1/8 of an inch. And that is an option. They do also come in metric. The actual target tooling kit comes in metric as well. These do come in metric, and many of the metric target tooling, many of the metric shank nests will actually have a 1 inch offset. Some of them have a 25 millimeter offset, but all of the metric nests have a shank diameter in millimeters, whether it be 6 millimeter, 5 millimeter. I believe the standard tooling kit in metric has a 6 millimeter. Another common accessory, another common piece of tooling is the flat nest. And once again, the newer flat nests have the cutout, which allow you to place the SMR down on an angle a little bit, which is useful if you're measuring something up high. And the flat nest is very similar to the shank nest, except it doesn't have a shank. And what it would allow me to do is measure that type of circle right there. Whereas with the shank nest or the pin nest, I would not be able to measure that inside wall as a circle. The shankless nest or the flat nest does have a chamfer around it on the outside, which does allow you to place the SMR up against that edge, and also prevents there from being any burrs along the actual machining of this edge from affecting the measurements, or if there is a fillet. So I will place the SMR in the nest, and I will be able to measure that as a circle. And I'm measuring that inside wall right there as a circle. Once again, the offset The center of the SMR is sitting 1 inch, mechanically sitting 1 inch off of this flat surface. And this wall that I'm placing it on is 0.8 inches away from the center of the SMR. So this entire nest has a diameter of 1.6 inches. That is precision. And that offset would be taken care of in the software. In CAN 2, you would actually use this, you would actually use the 1.6 inch shanked nest as your offset, even though it is a shankless nest. Because another way of thinking about it is a shank nest with the same height offset as this, but instead of having a 1/4 inch diameter shank, it has a 1.8 inch diameter, I'm sorry, 1.6 inch diameter shank. Another common piece of tooling is an edge finder or line edge tool. And this is precision. This has a straight edge, so that when I place the SMR on this nest, the straight edge is mechanically aligned with the center of the SMR. So therefore, I would be able to measure this line with 0 mechanical offset. Or I'll be able to measure that line with 0 mechanical offset. The SMR does sit 1 inch off the surface, and because it's a line, there's different offset features in the software for it. Many softwares do a plane projection. Some softwares do not. If you're working with software that does not do plane projection, or if you're doing a 3D line, then you know you are sitting 1 inch off of the height. This is a handy tool for measuring this as a line if I wanted to have this as the origin of my coordinate system. If I did not have this tool, or if I forgot this tool, or if I dropped this tool, and it is no longer precision, I could actually use the 1/4 inch shank nest to measure this as a line as well. However, and if I was to then use that as in part of my coordinate system, my origin may be off a little bit to the side, in which case I would need to translate the origin, or translate the coordinate system over to the side to take care of that. And I would do so by the radius of the shank. So these bits of tooling that I just went over so far are the most common tooling for most customers. There is additional tooling which is a little bit less common. Some customers may never use them. Some people may never use them. Some customers use them all the time. It does come with 4 construction balls, 4 tooling balls. They both go by the same exact name. And this tool that I do have does not appear to have a construction ball hole in it. I apologize about that. But this is used many times in automotive industries and many times in aerospace industries. This is a 1/4 inch shank or a 1/4 inch pin. And if I place this in a 1/4 inch hole, then I'm going to have a sphere that sits a 1/2 inch, the center of the sphere sits 1/2 inch off of the surface. Because it is a sphere, I can go in, I can measure it from any angle. And I can measure the center of the sphere from any angle. And if I was to have a variety of these, 5 or 6, 7 or 8 on the tool, then I would be able to find the center location of each one of those spheres. And if I had nominal points for those spheres, I would be able to do an iterative alignment or a best fit alignment to get back into a previous coordinate system. There are other uses for it, but some of the most there are other reasons that you may want to do this, but the most common use is in either automotive or aerospace. An automotive tool at its initial design phase or its initial build phase, an operator would go in and they would construct a coordinate system off of the base of the tool, and they would start working up and they would start putting pins and pads and details in all sorts of different locations. That tool is going to be in production or in use for however long that car is in production, and it may very well come to some time where they need to tie back into that coordinate system to move one of those pads or replace one of those pads or inspect one of those pads and verify that it has not moved. Because everything is now blocked on that tool, there's now a lot of electrical lines, hydraulic lines, etc. The operator would not be able to easily see the original base of that tool that they started building off of, which is where construction bolts or tooling bolts come in handy. What they also would have done during the initial build phase is place a lot of 1/4-inch holes around the tool near those pads and measure tooling bolts. And they would have on file the XYZ locations of those tooling bolts back when the tool was originally built. So now if they ever needed to come back in and replace an item or inspect an item, they would take those original XYZ locations that they had on file from when the tool was first being built, and they would do the iterative alignment on those. Each one of these is a 1/2 inch off, so they are all identical, which means it doesn't matter which sphere you place in which hole. Aerospace, very similar application. Okay. Sometimes in machine building or in other types of industry, a customer may choose to do that if they need to tie back into a coordinate system in a short period of time. If they're building a tire machine, or if they are building some other type of alignment machine, roller machine, or etc. They could do that. However, it is much more common to do that, or to use these in either the automotive industry or the aerospace industry. Because automotive and aerospace are traditionally heavy users of a laser tracker, we do provide that same. Down here in the bottom, there was a piece of foam that was covering it up. I've just removed that foam, and I've removed a 10-inch bar. This is exactly 10 inches long. The tooling kit does also come with a small little Allen wrench at the top. I'm not sure if you can see it, but at the top there is an Allen wrench, and there is a set screw. Oops. I'm sorry, as you can see, all of the other nests are magnetic as well. Actually, I can put the set screw back in right now. There's a time. But at the top of that, there is a 1/4-inch hole, which does allow me to put the 1/4-inch shank nest. Down here, there is another 1/4-inch hole. As you can see on a brand new kit, they do put everything in very tightly. In this spot right over here, there was a hard point, okay, with another 1/4-inch hole. this hard point does thread on to this bar. And right now I have a 10-inch long bar with a 1/4-inch shank nest, as well as a hard point adapter. And I can place the SMR over here. Now this is a difficult tool to use, and many customers do not use it, but many customers do occasionally have the need to measure either something that is very, very difficult to reach, measure 1 or 2 points that is very difficult to reach, or impossible to reach with the location of the tracker. For example, if I needed points on here, and the tracker was over there, then I would be able to place that point there, measure, 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 etc. And measure many points, 5 or 6 or 7 or 8 points. I recommend at least 8, and construct a sphere out of those points. The center point of the sphere is a point that's on the surface. And while it is difficult to use, if you needed to get the tracker over to here, but there is some other machinery blocking this point, then it turns to something that's otherwise impossible to just difficult. Another application is scribe line. Around this tool, I do have a series of scribe lines indicating the diameter of the bolt pattern. And if I needed to measure a point on that scribe line, I could do the same. As I mentioned, this is very difficult to use because it is easy to slip with this, which is why I recommend taking more than the minimum number of points to measure the sphere. I recommend collecting 8, 9, 10, 11, 12 points, several points on there, because assume that you're going to slip. If you slip once or twice, you will, one, possibly be able to remove the point, remove some of the observations, and salvage the measurements. But more importantly, if you were to only collect 4 or 5 measurements, you would have never noticed that you slipped and had an invalid point. You should also compare the diameter, make sure that you actually have an appropriate diameter considering the amount of tooling that's being used. Another tip when using this is you can't use this. You do need to get actual motion. Just doing this amount of movement is a very difficult sphere fit for many softwares, Cam 2 included, and you will not get a reliable sphere. The software is just not able to calculate a reliable diameter and then able to calculate a reliable center point. Next to the hard point, there is another sphere fit adapter. There was another adapter for the 10-inch bar, and it's called a sphere fit adapter, and it works off the same principle. I would have to say it is used by even fewer customers, is used by a smaller subset of customers. There are some customers that will never, ever use this, but in the automotive and in the aerospace industry, there are customers that will use this a lot. It works off of the same principle as what I just showed with the hard point, except you're using it in conjunction with the construction ball or the tooling ball. So along that same example as earlier, if I was measuring an automotive tool or an aerospace tool where I had a series of tooling balls or construction balls that I had nominal locations on and needed to do an iterative alignment for them, but some of them were blocked compared to where I had the tracker, and I needed to get them for either an appropriate number of points to do an iterative alignment or just to add more points so I could get a better iterative alignment, then I can place this on there And this takes what is typically a 1/2 inch diameter sphere and turns it into something more like a 10 inch diameter sphere. So a 10 inch radius sphere. And allows you to measure something that might be hidden. So. I'll put that back later. Along with the target tooling kit come 2 bushings. These are simply 1/4 inch holes on one side, allows you to place the SMR in there. And what it effectively does, it does raise the amount that the SMR sits off of here. What it effectively does is it changes the shank size. Okay. So, if I had a different diameter hole, and I'm sorry, I do forget the diameters of the hole, I will get them later on and add them to this video as text at the bottom. But if I had a different series, different size hole, and I wanted to, instead of measuring these always as circles, I would just be able to place that right in the center of the hole and measure that as a point. My offset would be in the up-down direction. I'd be to take care of that by offsetting it or projecting the point. Okay. These are not as commonly used because it does require that a customer is measuring only that specific size hole. However, a customer could always extend this same principle if they were measuring a lot of holes and all they really were interested in was the XY position and not necessarily the diameter. They can extend this by either making one of their own or ordering additional sizes of their own. We do not have a lot of different sizes, however, many machine shops would be able to manufacture that themselves pretty easily. I believe I've gone over everything except this. This is the offset plate. And this is a commonly misunderstood tool. And this is another tool that I would refer to in some ways as a concept tool. Okay? There are many times when I was measuring that I would use the same principle as what I'm going to demonstrate with an offset plate. However, I would want something much bigger. One of the first things about the offset plate the offset plate is a 1/4 inch thick. The offset plate does have a 1/4 inch hole in it. So, unfortunately, I do not have a part here that has this, but these holes right here are through holes, which means that the shank length is not impeding me from actually measuring this as a circle. Okay. However, if these holes were, let's say, only about 1/4 inch deep, I would have a very difficult time measuring this because I wouldn't be able to actually insert the shank all the way. And with that, in that scenario, I would be able to use this as a spacer and still measure that as a circle. Okay. I have raised the circle up from the surface by another 1/4 inch. So now my offset was originally 1 inch, is now 1.25 inches. I would need to address that additional offset in the software, but it took a measurement that was not possible. It made it possible. One of the things that makes that possible is the fact that this surface right here and this surface are parallel. They are ground machine flat and they are parallel. This is a precision tool. Okay, if they were not parallel and not precision ground flat, then I could possibly be inducing additional error because it would be sitting on an angle as opposed to sitting flat. Another example where I would be able to use this is on the edge of this granite table. The edge of this granite table does have a little bit of a slope. It's going down. And that slope that goes down is almost, or very close to, the amount of length that's on this edge. Which means that I may not be able to really easily place this edge tool on the side. Okay, I may only have just a little tiny bit of the edge tool that is touching the actual surface. And that's because of either the chamfer or the felt. So in that situation, if I had the tracker over where the camera is right now, I would be able to place this surface right there. Take a measurement, raise it up a little bit, take another measurement, move it down a little bit, take another measurement. Okay, and by raising it up and moving it down and moving the SMR up and down. Take a measurement, and fit a plane to this. And once again, this is somewhat of a difficult measurement to do because you do need multiple hands, and you do need to make sure that you are indeed holding this flat up against the surface, and while you're holding the SMR, you're not actually pushing back on it and making it so that the tool and the surface that you are measuring no longer have actual contact. So in this situation, I would definitely recommend measuring more than 3 or 4 points to construct the plane. I would definitely recommend 8 or 9 points to try to determine whether or not you did have an error by looking at the form of the max and min and possibly removing a couple of the points. However, so while once again I mentioned it's a little bit difficult to use, it is still, in this situation, it took what was an impossible measurement and just made it a little bit harder. Okay. I called it as much of a concept tool as well as an actual tool, because this is another common type of thing that, say that I was trying to measure over here, and in this situation I might actually have this blocking the actual laser beam as I'm trying to measure it. Okay? Let's just say it was a little bit closer, like that. Okay? It would, at this point, still be a difficult or impossible measurement in this scenario with this particular tool. All they would need is a bigger one of these. We do not offer a bigger one of these, but considering that this is just a machine ground flat surface, many facilities that use a laser tracker are indeed, or have access to machine shops, or already have pieces of metal that are maybe a little bit larger, that are machine ground flat surfaces. In a pinch, you can even use a gauge block. Okay. People do hesitate using gauge blocks for this though, understandably, because, well, if it falls, they're just ruin the gauge set. So, generally speaking, people are more inclined to just go to their machine shop, obtain a scrap piece of metal and say, machine that surface flat for me. And then go ahead and use that. And maybe instead of having something that's only about 3 inches long, they would have something that's about 5 inches long, and be able to perform those measurements because now they have the SMR up over this. So that's why I call it as much of a concept tool as a. Another example is another cross application of of the hidden bar, or the hidden point bar. And that is this surface right over here. Okay? I used this example before, but this is another place where I can use this example, and that is I can't place the SMR right over there where I have a tracker. Okay? If I had a tracker over there, I would be able to. But it may be inconvenient or impossible to move the tracker there. So, because this is a because these are two machine flat surfaces, and these two surfaces are parallel, I would be able to place this on that surface, measure a point, measure a point, measure a point, and construct a plane out of that surface. The SMR nominally has 3/4 of an inch offset. In this case here, this is 1/4 of an inch. I would need to offset this plane an additional 1/4 of an inch in the software. Once again, customer would also be able to do the same thing. If this was too small, they would be able to do the same exact thing by just getting a larger piece of metal and saying, okay, I need two surfaces machined flat and parallel. Do you have any questions?
The only question I had was in using the 1/4 inch shim when measuring an edge. Can the software compensate for that 1/4 inch that it's being pushed off of the edge?
No. No, it cannot. Not in the case of the tracker. Because it doesn't know, or in most cases not. Not in the case of the tracker. I should say, it would depend on the software. CAM 2, I believe, does have some of the automatic compensation. So I would actually have to double check on that in CAM 2. Certainly in other softwares, no. Okay? And the reason for that is, if I was to just measure this as a line, I have 3 points that are all along this line over here. But along with that, there needs to be another compensation point done off over here to say, okay, I moved it, I measured this way, as well as a plane to project on over here. And CAM 2 does do many of that. There are third-party softwares that do not operate that way, that will just measure this, this, this. That is my line, which is actually one of the reasons that this comes in handy so much. Okay? So it really does depend greatly on the actual software you're using. My assumption and the way I would work is teaching people, no, you need to take care of the software, whether or not you have a software application that is using additional information, such as the fact that I measured another point over here to say I'm moving off this way, and I'm measuring high, and I need to move down. Okay, then that software is using that information, but from a tool standpoint, no. And like I said, I know that third-party software such as Spatial Analyzer or Verisurf do not do that. CAM 2, we've been adding a lot more smarter offsets. So CAM 2 measured 4, did not. CAM 2 measured Q, did not. CAM 2 measured 10. I do not believe it would do that. Future versions of CAM 2, I obviously cannot comment on. Do you have any other questions? Okay. I'm sorry, to expand on that a little bit more, one of the reasons that CAM 2 does some of the offsets a little bit differently than many of the other third-party softwares that are used with the tracker is because CAM 2 is also designed with the arm in mind. So the way that you would measure the arm, the way you would measure this arm is by saying, okay, point, 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 and you've already measured that plane, and it's projecting a line, and then you come in with the comp off. Well, if there are no more questions on that, I would like to go over some additional tooling. I'd like to go over the 1/2" SMR kit. This is the 1/2" SMR kit. I took it out already, but the 1/2" SMR does actually, 1/2" SMR does sit in there. There is a lot of room for additional 1/2" SMRs. However, the 1/2" SMR kit only comes with one. 1/2" SMR kit also comes with a magnetic handle. The 1/2" SMR, while useful in getting to small areas, is also difficult to use because it's small. And if you have big fingers like me, it can be difficult to track around or actually hold on to and actually perform the measurements. Okay, so it does have a handle. It is magnetic. To release it, there is a little button to push down on, and that simply retracts the magnet enough where you can go ahead and release it. The 1/2" SMR does come with its own shanked adapter. This is a 1/4" shank. Okay, and the SMR is actually sitting, the center of this SMR is actually sitting a 1/2" off of that surface. So if I was to place this 1/2" SMR into a 1/4" hole, this is going to be sitting exactly 1/2" off the surface. Which, if you remember, is the same as the construction ball. So many places that actually have a need for a construction ball, very often they will actually replace this construction ball method with that, because it's easier to measure a single point than it is to be measuring a sphere. Not all places have done that, but a lot of places have started to. Along with the 1/2" SMR kit is another, it's actually called a TMR adapter, 1.5" TMR adapter, or a 1.5" adapter. And what it allows you to do is place the 1/2" SMR into a nest, and it mechanically places the center of the 1/2" SMR at the same location that the center of the 1.5" SMR was used. This was used very frequently on much older tractors before we had 3 separate TMR locations to allow you to even use the 1/2" SMR. However, it can also be used if you are using primarily the 1/2" SMR to do some of your measurements and you want to go back and check drift real quick, make sure that nothing has moved, make sure that the tractor didn't get bumped, make sure that the object you're measuring didn't get bumped or move, or due to vibration, temperature, etc. And you didn't want to go back to your toolkit to get your 1.5" SMR. You can just take this out and place that in the drift nest, even if they were originally measured with the 1.5" SMR. Do you have any questions? I do have 3 additional pieces of tooling. These are less, one of them's One of them is simply a metric version of what was in the standard tooling kit. And as you can see, it looks pretty much the same. In fact, you probably would not know it was different if you put the two side by side unless you looked at them very, very, very carefully to see that this one has a 6mm diameter. Yes, 6mm diameter shank, and this one is actually 25mm offset vertically. Whereas the one that was in the US version was 25.4mm or 1 inch. So you probably can't see it, but if you put them right next to each other, yes, there is a very small height differential. Okay? And I do not want to mix these up because I will confuse myself. And as I mentioned earlier, the shank nests come in a variety of sizes. They all work off the same principle. And in our product catalog, you can go in and you can see basically all sorts of different sizes, all sorts of different shank sizes. Another less common tool that is used more in aerospace, is what's called a 1/2 inch double vector target. And I apologize for not having a plate here that had a 1/4 inch hole in it, because this is another one that has a 1/4 inch diameter hole in it. But let's just say I needed to get a, let's say, we're going to do a couple ifs here. If that was a 1/4 inch diameter hole, and I needed to get that hole's vector. I did not need its position. I needed its vector. Okay? Measuring it as a point or measuring it as a circle is not going to give me that. If I measure it as a circle, I'm actually going to get this surface's vector. Okay? With it being a 1/4 inch, very difficult to get a probe in there and actually measure it as a cylinder, even if you were using a retro probe. Okay? What this would allow us to do is, another example is if that 1/4 inch hole is on a contoured surface. So what this would allow you to do is place the item in, measure 1 point. I'm sorry, you can't see. Measure 1 point, measure another point. Those 2 points create a perfect line. With the 1/2 inch SMR, that perfect line is in line with this shaft, this shank. So at that point there, I can construct the actual line. In the software, I can construct a line between these 2 points. This point actually sits a 1/4 inch off of the actual surface. So it's much more common in aerospace, where one of its most common applications would be aerospace, where there may very well be 1/4 inch holes placed around on a contoured surface. Okay, it is a specialty tool. Not very popular, but it is available to some of those customers. However, the same principle can be used for other types of tools. Okay. Technically, even with the 1.5 inch SMR, you could place the 1.5 inch SMR in a 1/4 inch shank, drop it in a 1/4 inch hole, and then take the 1/4 inch shank, put it on the 10 inch extension rod, drop that in there, and you still have the same exact item, just a lot bigger. Although that requires getting a lot of additional tooling. So for those people who are doing that, having one piece is much more desirable. Another less common tool is what's called the diamond shank. The reason I bring it up is because it's not very common, but when people start asking about it, the first thing they say is, "What is that? I've never heard of it." Okay, so I have one here, and figure I'd let you know. It is a 1/4 inch pin nest or shank nest. But I don't know if you can zoom in on that. If you look carefully, are you able to get that? If you look carefully, two edges are shaved off. Okay, so this can be very useful for measuring a lot of slots. Okay, you measure. Oops. That part there is a line, and then this part over here has the actual circle. Okay, not all software has slots available to them. Cam 2 does have a slot available to it where you'd be able to go in and measure it as a slot with the 1/4 inch pin nest and get a lot of the information, but not all software does have the slot feature included in it, so this allows you to actually do the measurements. Okay? And in addition, you would still be able to use it, provided that you were careful, still be able to use it as a 1/4 inch shank nest. So it would be able to save some operators time in going back and forth between switching back and forth between tools. As I mentioned, this is not a very common tool, but probably about once a year or once every other year, all of a sudden you'll get an account manager saying, "What's this diamond shank nest?" Okay, so that's why I had one. I wanted to show it to you. I think I went over all the tooling I brought with me. You have any questions?
Mm-hmm.
Thank you for your time.